Hello, everyone. This is Belinda Carr. Welcome back to the Movers and Breakers podcast, where we dive into the world of construction and explore the stories of people and companies who are shaping the future of our industry. From the latest innovations to the challenges and triumphs of everyday professionals, we bring you the inside scoop of what's happening in construction. Today, I'm speaking with Chris Anderson, CEO of Vantem. Thanks for joining us, Chris.
Thank you, Belinda. Really appreciate your interest. Looking forward to it.
Yeah, when I came across your company and your panels, I was very interested in learning more about them. So for anyone who hasn't heard of Vantem before, y'all produce high efficiency, low embodied carbon, net zero structures at competitive costs. That seems to be something that everyone wants to achieve but hasn't been able to. So I'm very interested in learning more about your story and the product. So let's start with you. How did you start this company?
Sure. Well, the Vantem comes out of a prior company that I started with a business partner right out of college, and what we were doing in that company was building and manufacturing sustainably harvested wood products, mainly windows and doors and flooring, things that go into construction. And one of the things that we kind of noticed and realized as we were, developing that company was that here we had these really technologically advanced, very productive factories making the windows and doors. And then you go to the job sites and, they're going into homes that are being built like they've been built 100 years ago, the same systems, same processes. And that was kind of the spark of, there must be a better way of doing this. And so we,
Like a 16-inch tolerance window meets a quarter-inch tolerance house.
Absolutely. And then you have these, you don't see a single, piece of high-end technology really on the job site usually, right? It's all hammers and nails and things like that. So, that's when we decided, let's convene a group and start thinking about how we might be able to make the actual home itself better.
And that led you to creating these high efficiency panels that I understand a lot of it is proprietary, but could you tell us a little bit more about the panels themselves?
Yeah, absolutely. So in that group, the one thing we started by doing was looking at, what have other people done to try to increase quality and productivity in housing. And I think that, what we did set out as a goal from the very beginning was to make sure that whatever we did would be a way of building houses that would be cost competitive globally, right?
Ultimately, that's the deciding factor to adoption, right?
Right. I mean, I won't say it's easy, but it's a whole lot easier to do something, that's expensive, but that few people can, the premium stuff. But what the real challenge is how do you do a really great product that actually most people can afford? So that was absolutely a goal from the very beginning. The other thing that was a goal was that trying to help with that balance of human need for housing, at the same time not making the energy crisis and CO2 and carbon emissions worse, right? So we wanted to make it more affordable, but we also wanted to make sure that those homes that we produced would be ones that had a very low carbon footprint. Okay, so then we put together a really talented team, started looking at everything that has been done in the world. And we did see that, for 70 or 80 years in the US and parts of Europe and Japan, people have been using structural insulated panels, right? So we were really intrigued because it's a cool idea. It's a simple way of building a really highly thermally effective home. But those panels typically are built with a wood-based material.
Like usually OSB, it's an OSB sandwich, right? With EPS or XPS in the middle. Yeah.
There you go. That is what is typically done. And whereas that's a good improvement, it still has the challenges that you need to put more layers on the outside to protect it from the elements. You have to put drywall on the inside. And in most of the world, not everywhere is wood considered something that you can really use. People are really afraid of termites and mold and all this kind of stuff. So we felt, well, listen, if we could replace that OSB with something that was more in the cement family that still, allowed us to build a quality panel with all the same attributes, we get it. And it was harder than we thought. It took a number of years to figure out how to do that. a lot of trial and error on different kinds of ways of doing it. In the end, we landed on really what is more a ceramic type of material. And that is what is the core of Vantem's intellectual property today. So we build that panel with our Vantem board, which is the ceramic material on both sides. And that solves all of those key problems. So we have all the benefits of the simplicity and thermal effectiveness of a structural panel without the downsides, because that ceramic board is weather resistant, it's fire resistant, it's termite resistant, mold resistant, all these things, and it's paint ready. So we're able to deploy it internationally. We're able to reduce costs because it's simpler, right? And we have all that thermal efficiency, which was part of our initial goal.
So it sounds like the panel that you've developed is an all-in-one panel. It takes care of the structure. It takes care the structural components. It's an exterior face and an interior face, and it's almost a weatherproofing barrier as well.
That's exactly right. Yeah. So the panel itself, like you say, is structural. So it doesn't need additional wood or steel to hold loads, right? And we can build the entire house and up to 3 stories, 4 stories with just the panel without additional reinforcement. So they are very, very structural, right?
3 to 4 stories with interlocking panels and no additional structure?
Yes, exactly.
Wow.
Yeah, they're very, very structural. And to those that are, kind of on the engineering side and want to get a little bit wonky, why is it so structural? Well, they work like I-beams, right? So when you build this panel, it's like an I-beam. Now imagine standing an I-beam up on its, vertically, it'll be very, very structural. And that's how this works. And yes, those faces are paint ready. So once we stand that panel up and make a wall with it, all you need to do is paint it. It's ready to go. You don't need to put drywall on the inside, and on the outside, you don't need to put additional, cladding to protect it from the elements. So it's a lot faster, a lot less expensive to build with.
So it sounds like when you develop the panel, creating something that could be used all around the world was one of your key motives, right? Why was that? Why? Because construction is so regional. I've noticed, like, not even just within a country, within a certain state, it differs so drastically from another state. But why was it so important to you to create something that could be used not only in a country, but around the world fairly easily without much modification?
Well, I think candidly, we were very ambitious with what we wanted to do. We wanted to create a product, a system that would be truly scalable. And why? Well, because affordable housing, cost-effective housing is a universal need and a universal problem. Energy efficiency, emissions reduction is a universal problem. It's everywhere, and it's something that to be impactful, you've got to be able to address it all over the world. And that was, at the end of the day, one of the core elements of why. And so, we did start out proving the concept overseas even, right? So we started proving out the system, doing our initial testing and our initial installations in South America, in part because if you can do it in those low labor countries, if you can do it in places where construction is less expensive than in the US and in Europe, then you're absolutely going to be able to compete, in places where construction's more
That's
expensive.
a good point.
And so,
Yeah.
that's one of the reasons we started where we did, even with our rollout.
So how has it been accepted in South America and other countries where you've used this system? Have people been very
Really well.
receptive?
Now,
Yes.
obviously, the very first time you describe the system, people are somewhat skeptical,
Yeah.
right? They're like, oh boy, how is this possible? But I would say universally, once we've built a home or a structure with our system, and people are able to see what it looks like and understand it looks exactly like what they're used to seeing, with traditional construction, even in South America, where traditional construction is concrete and brick. Our homes, once you're done, they look and they feel like those structures, with one important difference, which is people truly end up being amazed when they walk in and they realize how much more comfortable the homes are because of the thermal efficiency, and so that has been, a universal response to walking into our homes.
Because you all have almost eliminated thermal bridges, because it's just your panels are continuous pieces of foam within these ceramic inner and outer faces. So you'll have no thermal bridges at all.
Exactly. And so, well, when you look at the way people build in South America and really the rest of the world, there's very little insulation at all, right? So automatically what we're doing is usually 90% more thermally efficient than a solid brick wall or solid concrete. Now, exactly to your point, in the United States now, when we turn our attention to how do we perform versus wood framing, we perform a lot better because of the lack of thermal bridges or the elimination of thermal bridges, right? Because a traditional U.S. house, you'll have wood studs that are interrupting that insulation layer every 16 to 24 inches on average, right? And those really impact the thermal efficiency of the envelope.
Absolutely. I have a thermal infrared camera, and whenever I do look at my house in summers, it is insane how much heat we're losing through every single stud, through every single rafter. They just show up as bright red beams and elements on the thermal infrared cameras, and it's very disappointing how poorly we build over here. I mean, we're just so used to these energy guzzling homes, and we don't know any different. So a system that you have developed, it can truly change the market. And to the everyday homeowner, they don't understand, or they don't need to know the ins and outs of how their house is built. All to them, what matters is that their energy bills are much lower, they're more comfortable in the home, and it looks just like a typical house. To them, it's not something that's that's going to make them feel uncomfortable when they live in the home.
Well, absolutely. And so, I mean, I think the part that some people focus on, but I think that is really important for everyone to focus on, is that 40% of all carbon emissions in the world are the built environment.
That's true.
Right? And I think a lot of us assume that's the embodied carbon. That's, the carbon that it takes to that it takes to build the
Build the
homes or
structure.
the structures. That's not true.
It's operational carbon.
It's the operational, exactly. So it's all that energy that it takes to heat and cool and light the structures that is the overwhelming cause of the emissions. And so if we focus on that, we are focusing on the most important part of the problem. And so, I think that as people look at their homes, and I think it's great that, your example of looking at the infrared pictures of typical, people can go online, right, and see some of these. If they don't believe it, you'll see exactly what it is. Because, for example, if you take a wood frame wall, we're told, hey, this wall, we built it to R19, for example, right? Thermal insulation. Okay, that's true in the sense that they used R19 insulation in the wall. But what really is important, and most builders don't talk about, is what is the whole wall value,
Exactly.
right? What is the true performance? And so that R19, it's not unusual that because of the thermal bridges, it's really performing like an R12. Right. And so that's just a massive difference. Now, with the Vantem wall, as you pointed out, we don't have any of the thermal bridges. So when we build an R19, and actually we usually build more than R19, but if we were to build an R19, the whole wall is performing like an R19 wall. So we do not have a loss through those thermal bridges. The other part that's important that people need to focus on is air leakage, right? So the other problem is that the homes, as we build them today with wood framing in particular,
because they have so many layers. Yeah.
Right. So many parts and so many things breaking up that envelope all over the place that 20 to 30% of the energy in a home is actually lost through the leakage of air through all those cracks.
Exactly.
And, typically to try to solve that in traditional construction, it's quite expensive. I mean, there's just a lot of tape and a lot of all kinds of stuff that needs to be done, and it's really very difficult to do. And so, the other benefit when you're building with a panel, especially our panel, is you just don't have those breaks. And it's not hard for us to do so. So we actually are able to get that thermal envelope to be thermal efficient, airtight, without the cost premium that typically is associated with getting there.
It sounds way too good to be true. How do you manage to build such a high efficiency panel and keep it cost competitive to traditional construction?
Well, I mean, if you think about how complex traditional construction is, you can kind of start doing the mental math. You have a lot of layers, a lot of parts. So
A
that
lot of
means you have a
labor.
lot of labor.
Yes.
Exactly. You have a lot of labor. And then you have a lot of extra parts because there's things that you don't really need if you're doing it more efficiently. And so that's really what we're doing is we're stripping out the labor and kind of the labor overage, if you will, and we're stripping out a lot of the unnecessary parts. Now, the other part I think that is important in the way we achieve that goal is that the way we prefer to deploy our system is with offsite manufacturing, meaning modular manufacturing, where we're building our homes in a factory.
Okay.
So that really allows us to maximize all the efficiencies, right? Because now what's happening is that the same dynamic that allows us to reduce labor and materials also allows us to make a less expensive factory that's highly automated, right? We don't have as many parts, so the automation is simpler and cheaper. And so what we're doing today and the way that we've started our rollout in the United States is to build modular homes, right, in a factory, which we've done in South America, but now we're really moving forward very strongly doing it in the U.S. Using our panel, and the effects of that are that we're able to drive down costs even more and produce a lot more volume, which is back to the whole issue of scale.
Absolutely. So I was actually going to jump into that part now. Y'all have created a name for yourself in South America and in Europe, and y'all have proven that your wall systems work. But y'all have built schools, homes, and I've gone through your website. I saw a whole lot of case studies and projects that you've built using the system. And now you have finally come to the States. Y'all have a presence in Georgia, I believe.
Yeah, that's right. So yeah, we built about 3 million square feet overseas, and then about a year and a half ago, felt ready to embark on full scale rollout here in the United States. And what we did initially was get our code approvals for the U.S. So we've got approvals for we can build everywhere in the U.S. Up to 3 stories, and we're going to be getting kind of that code approval up to 4 stories hopefully soon. And the other important thing that we did was bring on board an important partner, Breakthrough Energy, which is Bill Gates's fund focused on carbon emission reductions. We brought them on board as an investor about a year ago to help with that rollout, and they've been really, really instrumental in us doing so. And as you point out, the first important step for us has been the purchase of an existing modular factory in southern Georgia, Affinity, a great company. They've been building really high quality homes with wood, as is typically done. And what we're in the process of doing is we're going to still build the same high quality homes, keep all the same attributes that Affinity is really, really known for, but we're going to be adding attributes which are even more energy efficiency, and especially the offer of net zero homes out of that facility as soon as we have it fully transformed early next year. So we're really, really excited about that, and we're looking to build on it. So our eventual goal is to build or acquire 20 factories in the United States over the next 10 years. So this is our first step.
That would be truly exciting if you have the same clients, have the same type of houses, and you'll just make this switch behind the scenes almost, where you suddenly switch from traditional wood construction to these high performance panels, and the clients and the customer base don't even realize that y'all have made the switch, but they suddenly have these high performance homes that offer all these extra benefits that they wouldn't have been able to access earlier. But I do have a question about the exterior of the homes that y'all built. Since y'all use these ceramic panels, how do you manage to achieve say a traditional brick appearance? Do y'all build these thin brick panels on site after the home is constructed?
No, it's a great question. So whereas with our panel, one of the options, the least expensive option, is to paint the exterior or to put a textured paint on it that looks like stucco, right? So that's the least expensive way to go. There is no restriction of doing what you traditionally are used to in the United States, right? Of putting, you can put vinyl siding on it if you want to. You can put, plank siding, wood siding. You can put brick veneer or stone veneer on those panels with no restriction whatsoever. It adds a little bit of cost, but there's no restriction and nothing that impedes us doing that. And in fact, at Affinity, one of the specialties of Affinity, what they're really known for is not just really high quality, but Affinity does a high amount of customization, which is kind of unusual in a factory built,
Yeah.
home. And so the homes we'll be building at Affinity are very likely going to have the type of cladding that you're talking about, decorative
Rain
cladding.
screen, yeah.
Yeah, exactly. And that's all done in the factory. That just about all of that work is done in the factory. So when the home is delivered, 80% of all what is typically on-site work has already been done in the factory, right? The
Okay.
only things that you do on-site are the foundations and kind of that final thing that's the stitch up between, if you have several modules to make up the home, you've got to kind of stitch them together, right? So they look right.
Yeah. But I guess we didn't touch on the roof of these structures, because that's a major source of heat loss with all these crazy vented attics that we have. How do you address roofs with your structural system?
Yeah, great question. Well, so our panels work great as walls. They also work great as roofs and floors. So the modules that we build can have the roof made from our panel, and it's a very effective way of creating the complete thermal envelope. So typically what we would do is actually run our panel horizontally where the ceiling is of the home. What you would
Yep.
typically look to as the ceiling, the horizontal surface. That would be our panel that's sitting on top of the Vantem wall. So you have this really airtight, thermally effective structure, kind of like a beer cooler, right? It's all very airtight. And then you can put on top of that
Like a
whatever shape
decorative
of roof
pitched
you
roof
like.
or whatever
Yeah,
you want.
exactly. Anything you want just sits right on top of that. So you've kept the thermal envelope below the roof line.
Very interesting. So that could be metal roofs, that could be wood frame roofs, any sort of pitches that you want. It could still be accessible, but the home itself, the livable space, that is enclosed, airtight, weatherproof. That's separate from the roof structure or the attic space.
Exactly. Yeah,
Very
exactly. Which
interesting.
is not unusual for even traditional homes, right?
Yeah.
For the attic space not to be conditioned. But in this case, you have, again, a very effective thermal ceiling, the thermal roof system that
Yeah.
is uninterrupted, with wood framing and all the other things.
What challenges have you faced bringing this system to the States? Because it can't have been a seamless transition. Has there been have you had to educate a lot of clients and consumers on the advantages of your system and how it's not going to be some drastic shift that's going to make them uncomfortable? Had What about getting the system code compliant? Has that been a challenge?
Well, so yes, code approval in just about any country can be quite complicated. In the United States, it definitely is. It's costly, time consuming, and was a really important achievement for us. So we spent over a year with testing, several $1 million worth of investment, getting the code approvals so that we could build the product in the United States. It's really a huge undertaking. Now, once you're done with that, the key challenge is convincing our customers, which in our case we work directly with developers that are looking to do high energy efficient, cost effective housing. And the main thing they want to know is this house going to look and perform the way that a traditional house is going to look and perform? And And the answer is yes. And some of them have flown to South America to look at our product, and they understand that it absolutely performs that way and looks that way. So um, it honestly has not been as difficult as even we thought it might be to convince the market that this is the way to go.
That's exciting. I'm glad for you because we need something. We need a disruptor in the housing market. The way we build, it's not sustainable. We cannot keep building these energy guzzling homes because the problem I see is that there's such a huge demand for homes and it just keeps increasing exponentially because our population's increasing too. But we're building so cheaply that we're putting such an enormous strain on our grid. Our grid cannot keep up. Our homes are unsustainable. It's just this vicious cycle that we need someone to break. And the system that you have built with these high performance homes, that could really help break the cycle and help us focus on quality, not just on the quantity of home that we build. So I'm excited to maybe come visit your factory when it's up and running and experience the homes themselves and see the. I'm sure you can feel the difference when you're in the house. But what sort of advice do you have for someone in our old school construction industry that's so resistant to change? What advice do you have for someone who wants to build better while remaining cost competitive? It's a very difficult thing to achieve.
Yeah, so I think a couple things come to mind. The first thing is seize the moment, seize the opportunity. And this is the time to get involved and with energy efficiency. There was a great article, I think it was yesterday in the New York Times, talking about how renewable energy production in the United States is increasing at a rate that was not predicted, even by those in industry. I mean, it is outpacing prediction in a great way. So the time is right. I mean, the market wants it. People want it. Frankly, there are now, some interesting policies at the government level that help, with it through the Inflation Reduction Act. So it's absolutely an opportunity. Don't think of it as a threat, right? And then the other part of the advice I would give is that you can't expect new results doing the same old stuff over and over again, right? I mean, that's the old axiom. What you need to do is rethink the system, right? And that we did it, we rethought it, we came up with one way of doing it. I'm sure there are many ways of rethinking this old, 100, 200-year-old technology that we're currently using, and to do it better. Those are the two key portions of it, and it's something that's urgent. It's something that's absolutely needed. In the United States alone, we have an affordable housing crisis. We have absolute backlog of demand that is not being met. Wow, what an opportunity! Now, what is important is that to make that possible, you cannot be charging a premium for what you do, right? You can't have this green premium and think it's going to really be scalable. So those solutions have, that one sets out to create, have to be able to be on par with costs with traditional, but doing it better. And I think it's possible because there's just so much inefficiency in the old ways of doing things that if you focus on figuring out how to reduce those inefficiencies, you should be able to be competitive.
And your advice of like seize the moment is so relevant right now, because I feel a shift in the industry in the last 3 years. Like all these issues have just bubbled up to the surface and they're not going away. Whether it's the skilled labor shortage, it's the material shortage, the rising cost of materials, everything is an issue right now. People try to suppress it for so long, they try to ignore it. And then over the last 3 years, we just cannot ignore it anymore. So solutions like what you have come up with is very needed. And I think it's come at a time where it's going to be accepted, I think, by the industry at large too.
We're already seeing it. I don't think it's something that's going to come in the future. I think it's already here.
Absolutely,
I mean, really,
yeah.
when we have conversations with developers that are learning about our system and we're they want us to start producing now for them. I mean, it's immediate because we are, like you say, the developers and the whole construction sector is feeling the effects of this accumulated inefficiency and problems that have not been resolved. And so, for anybody that's in the business, you look at it and you understand it's not sustainable. And you understand that um, from a business standpoint, if you're able to reduce those risks that you mentioned, the kind of the labor cost risk, the material cost risk, and some of the other ones which are not yet mitigated, which are environmental costs over time and so forth, that you will have a very competitive product in the marketplace, and that's just good business. And when you're able to kind of marry good business with
A good
goals
product.
that are
Yeah.
right, and goals that are socially beneficial to everybody, then you've just got a great winning formula.
Yeah. Thank you so much, Chris, for sharing all that info with us. If people want to learn more about Vantem, what's the best way to reach out to you or learn more about the product?
Go to our website, vantem.com. Tons of information on there, and certainly feel free to reach out. There's some contact emails if you'd like more information, and we're happy to have somebody on our team you reach out and explain stuff. And certainly looking forward to seeing you at our factory as soon as we have it completely converted to the Vantem system, and we'll have some nice demonstration homes that are going up in the southeast here shortly too. So we'll hope to see you there too.
Absolutely. Yeah, I'm looking forward to that. Thanks to you once again, Chris. Appreciate it.
All right. Well, thank you so much, Belinda. Real pleasure.